Hey everyone, so in this video what I want to do is give you a short introduction of how to find a derivative of a polynomial, and once you figure out how to do that, I can guarantee you that you'll be able to figure out any derivative of any polynomial. Okay, so basically, let's say I have some function. You all know what a function is, so the function can be written as, whoops, that's the wrong color. So I can write the function as f of x or y, it doesn't matter, you know. So I'm just gonna write f of x. Let's say I have some function that's I don't know, ax to some number n, then plus bx, and now it's 1 degree less. So n minus 1 plus cx to the n minus 2, and then it keeps on going like this, dot dot dot, up until I get, you know, just some constant. Okay, so I'm just gonna call that I don't know. I'm just gonna call that a0 for constant. Okay, and it'll keep on going down until I get x to the n minus n, which will be 0. So basically, x to 0 is just 1. So that's the same thing as just saying the constant in itself. Okay, if you look at the formal definitions, okay, the formal definition will have something like a0 x to the n plus a1 x to the n minus 1, and then I'll keep on going until you have like c just all by itself. Okay, but it doesn't matter. Basically, the formula still remains the same, and I'm just gonna go over how to figure out the derivative now. So let's say I have just one term in the whole function. Okay, so my f of x is equal to a x to the n. That's it. That's my whole function. So how do I figure out the derivative of the whole function? The thing I do, the derivative is denoted by d over dx. Okay, so that's first thing. Okay, so d dx, derivative of f of x, is equal to, we keep the coefficient the same. We don't touch the coefficient. Okay, so I'm going to rewrite the a again. Then I'm taking it with respect to x. So I'm going to keep the x. Now, what I'll do is the n, take 1 away from that. So whatever this number n is, it could be 1 million, it could be negative 1 million. Okay, so I'm going to take n minus 1. Okay, and then I'm going to multiply the whole thing by my original exponent, which is the n. Okay, so when I simplify that, I get a n x to the n minus 1. So that's it. This is my derivative of function. So for example, let's say I have something like f of x is equal to 2x squared. Actually, I'm gonna write it as 3x squared. Okay, so what is derivative of f of x with respect to x? Okay, so I'm gonna keep the 3 the same, not touch it, get the original exponent down, multiply it with the coefficient, keep x the same, take away 1 from the top, so 2 minus 1. So what is 2 minus 1? It's 1, right? What is 3 times 2? 6. So it's just 6x to the 1, but I don't need to write the 1, you know, it's just 1. So the derivative of 3x squared is 6x. Okay, but what happens now? What do you think happens if I have some function like f of x is equal to 3x squared plus something like 10x? How do I figure out the derivative of this whole function? The thing is, we go term by term. Okay, so the first term over here is 3x squared. So the derivative of the entire function is this. We go term by term from left to right or right to left, doesn't matter. As long as they're adding, okay, there's completely different rules for when you're dividing functions or multiplying them, but we'll get to that later. So this right here, we're gonna go term by term. What is the derivative of 3x squared? Okay, So we keep the 3, bring down the exponent, so multiply by 2, and then keep the x, subtract 2 minus 1, so we get 1. I'm just going to leave it like that. And then I take the sign over here. This is a plus. If that was a minus, I would write a minus. So there's a plus right here. In the derivative of 10x, we take it term by term. So keep the coefficient, keep the x, bring the 1 down from the original exponent. So I'm just going to write it multiplied by 1. And then this is 1 minus 1, because I'm taking away 1 from here. This right here is just 0, or sorry, x to the 0, which is just 1. So now my derivative of 3x squared plus 10x is 6x plus 10. Okay, so on the next slide, I'm going to do a couple more examples so you get the hang of it. So let's say I have this function over here. I'm going to say 4x cubed minus 3x squared. Actually, I keep on seeing 3x squared over and over again, right? So I'm just going to write it as x squared. Plus 9x minus 4, and then plus x square root of x. Okay, this is a good one. So how do I figure out f prime of x? Well, f prime of x, or the derivative of x, is sometimes denoted as df of x over dx, or it's sometimes referred to as f prime of x. Okay, so this right here is the first derivative. So I'm just going to write this, f prime of x. We go term by term. What's the derivative of this term over here? So we keep the coefficient, bring down the exponent, keep the x, subtract 1 from the exponent, so that's 3 minus 1, so that's 2. This is a minus, so I keep a minus. Keep the coefficient is 1, I'm not going to rewrite that down. Bring the 2 down from the top, keep the x, 2 minus 1, so that's 1, so I'm not going to rewrite the 1. Take the plus, take the derivative of this term now, 9x. Well, derivative of 9x is just 9, right? We saw that. Similar problem in the previous slide. And then, what's the derivative of a constant? Well, I have a minus over here. So I'll keep the coefficient, right? This is the same thing as saying x is 0, right? Bring down the 0 into the bottom, multiplied with the coefficient, and then I say x to the 0 minus 1. Well, x to the 0 minus 1 is 1 over x, but 4 times 0 is just 0, right? So the derivative of a constant is simply 0. And that's a general property that you should remember forever. Okay? Then I take the plus. Over here, I'll keep the x, keep the coefficient, which is 1. But what's my exponent? Well, square root of x is the same thing as saying x to the power of 1/2, right? So I'll bring down my exponent, which is 1/2. Alright? And now subtract, take the original exponent and then subtract 1 from it. So what is 1/2 minus 1? Well, it's negative 1/2. So we'll clear this up a little bit. So 4 times 3 is 12. X squared minus 2x plus 9. And then this 0 over here doesn't matter. Plus 1/2 times 1, which is just 1/2, times x. And what is 1/2 to the 1/2 minus 1? It's negative 1/2. And if you recognize x to the negative 1/2 as 1 over square root of x, then that's perfect, that's great. But if not, you can leave the answer in this term, unless if your professor or teacher wants you to simplify this further. So I'll just simplify this. So f prime of x is equal to 12x squared minus 2x plus 9 plus 1/2, and then multiplied by 1 over root x. So that's it. That's our answer. It's pretty simple. Whoops. It's pretty simple. And yeah, so hope you learned a lot in this video. And before I go, I'll just do a quick property. So quick definition, recalling the definition again. Okay. Derivative of a function, okay, if it's x to the n, ax to the n, and where a and n are some numbers, what we'll do is a times the n times x to the n minus 1. Okay? If my function or my term that I'm taking the derivative of is a constant, some constant, okay, then the derivative of that constant will always be 0. Okay, so that's it for this video. Hope you liked it. I'll see you in the next one.